Good evening, student. Today we are going to learn the last topic in our syllabus, recursion. So the content is what is recursion, how we are going to write program in Java for recursion, and the various types of recursion. First of all, what is recursion? It is a function called by itself. A function is keep on calling itself until a particular condition is occurred. And it is an efficient method of programming. Why we telling this as an efficient method? Because it requires less amount of code. It is reducing the number of coding lines in your program, so that it's reducing the space in memory also. That's why recursion is called as efficient method of programming. And you should know two different terms. One is base case and another one is recursive case. Base case is the condition that terminates the successive method call is called as base case, and the calling statement is called as recursive case. Why we are using recursive function? For writing recursive function, you need minimum number of variables because it is keep on calling itself. Mostly you will use recursive function in linear equations, and in linear equations, all the linear equations are calling itself, the same variable is calling itself again and again. That's why the minimum number of variables are used to develop the logic, and as the function calls itself, application of iterative loop is ignored. Yes, as we are using recursive, there is no need of iterative loop, and recursive algorithm is readable. As it is requiring less number of coding lines, it is easy to read, it is readable and efficient, and easier to debug and obtain correct, that is error free result. And there are four different types of recursion: linear recursion, mutual recursion, tail recursion, binary recursion. First one, linear recursion. So you will use linear recursion in linear equations. For solving linear equations, you will go with linear recursion, that is sequential way of executing the statements. Mutual means imagine you are having two different methods, method A and B. Method A is calling method B and method B is calling method A. So if you want to write applications, or if you want to execute statements in this order, then you should go with mutual recursion. Next is tail recursion. You will call a function call within a block of function. If you want to use tail recursion, always the function call will be at the end of the function block. Then it is called as tail recursion. Binary recursion. If you want to call a particular function in more number of places, in more than one place, then you will call it as binary, as it is binary. By is means to 2. If you call the same function within a same function block for 2 times, then it is called as binary recursion. So now we will discuss an example for recursion. Factorial using recursion. This will comes under linear recursion. So first you should know how to calculate factorial. N factorial. For example, you want to calculate 3 factorial. Then the value is 3 into 2 into 1. So for n factorial, you should write 1 into 2 into 3 into 4, etc. up to n. The linear equation to solve factorial is n factorial is equal to n into n minus 1. Now look at the equation. Here the number of variables required is only 1, n, and this n is repeated again and again. That's why this linear equation is called as, it is in recursive nature. To solve these kind of equations, we need linear recursion. Now look at the properties. If n is equal to 0, n factorial is equal to 1. This is what actually the termination condition. If n greater than 0, then n factorial is equal to n into n minus 1. You should recursively call the factorial. So now see, for example, n is equal to 2. How you have to find the 2 factorial? 2 factorial is equal to 2 into 2 minus 1 factorial. Again, 2 minus 1 factorial is 1 factorial. Here you have to apply the formula. 1 factorial is 1 into 1 minus 1 factorial. Then 2 into 2 into 1 minus 1 factorial is 0 factorial. Again you should apply a rule. So you are keep on calling the same again and again. That's why it is called as recursive, and we are going to use recursive function to eliminate these many number of times, these many number of statements. Now see, 0 factorial is a terminating point. So 0 factorial is 1. So 1 will be returned here, and then 1 into 1 will be calculated. This will be returned in previous state. 1 into 2 is 2. This will be returned back at last. So the value of 2 factorial is 2. So now I am going to change this as program. So you should write separate function. See here, public static long fact. Fact is a function, and you are passing a value to be you are going to pass a value. For that you want to find factorial. What are the conditions you have to check? You simply check n greater than or equal to 1. If it is n greater than or equal to 1, you are going to write the equation n into fact of n minus 1. So n into n minus 1. So this fact of n minus 1 will be called again and again until it terminates with 0 factorial. So once it reaches 0 factorial, it will return 1. So the same should be called inside the main function. So see here, now in main function, the program will always start from main method. Main method, so int n is equal to 6, factorial is equal to fact of n. So now fact of n, this method will be called program control will come to fact function. It will check the value of n. Now n is greater than or equal to 1. So it will return n into fact of n minus 1. So again the function will get called, it will check the value of n, function will get called, keep on it will call once it reaches 0 factorial. Once it reaches 0 factorial, it will return the value from backwards. So at last you know the value of 6 factorial. So this is what an example for recursive call. That's all. In this session you learnt what is recursion, what are the different types of recursion, advantages of recursion, and one example program for recursion. Thank you.